we're going to model percents. A percentage is a part to whole ratio where the whole is always 100. So it's a part to whole ratio. Ratio means fraction. So it's a fraction that says part to whole, like that. So part to whole fraction where the whole is always 100. The whole is that my numerator or my denominator? In this case, it's my denominator. And if it's always 100, that means when I'm talking about percents, my denominator is always what? Always 100. So it's going to be the part, whatever the part is, over 100. So if you even look at the percent sign, it's 2 zeros. How many zeros in 100? It's 2 zeros in a line. It means out of 100. So that's why the percent sign looks the way it does. It's actually 2 zeros that tells us percentage out of 100. That's what that means. Okay, everyone's seen the percent sign, right? With the 2 zeros and the slanted line, that's what that means, out of 100. All right, so we have these charts below here. What these charts mean is, well, there's 100 squares in each chart, right? Why do you think there's 100 squares? Because percent is out of 100. So if I think about this, each square represents what percent? 1%. Each of these squares is 1%. So if I want to figure out, well, what percentage is shaded, I just need to count the number of shaded squares, right? So if I count them, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then there's 2 rows of that, so that's 20. And then I count 1, 2, 3, 4, 5. So what's my total? 25. So what would be my percentage? 25%, because it's 25 out of the 100 squares that are there. Does that make sense?
Yes, sir.
All right, so now they want us to make a part to whole fraction or a part to whole ratio. And so what I would say is 25 out of what? 100. 25 out of 100. And so now we look at, well, how do we make that a decimal? So the question is, how do I make any fraction a decimal? How do I make any fraction a decimal? Not just 25 over 100. How do I make any fraction a decimal? Want to give it a shot? Sure. That is the decimal, but how do I get there from a fraction? Emily. Divide what? Perfect. So she said we divide 25 by 100. She's absolutely right. I cannot stress this enough. I don't care what the numbers are. Every fraction is a division problem. Every last one of them. It's always numerator divided by the denominator. Always. Okay. So my numerator is 25. My denominator is 100. So I'm going to do 25 divided by 100. Okay, so when yes, sir. I don't want the answer yet. Can I put 100 into 25? What do I need to do? Yes. Add a decimal and then a 0. 100 goes into 250. Anyone? Twice, right? 2 times 100 is 200, leave 50. Another 0, bring it down. 100 goes into 500 5 times. So the decimal is 0.25. Now, here's my question. What do we notice about 25% and 0.25? What is the only difference between those two numbers? Outside of the sign. Don't worry about the percent sign. What is the only difference between those two numbers? What? The decimal, right? So the decimal, where's the decimal in that 25%? Where's the decimal in 25%? Good, it's behind the number. Anytime you don't see the decimal, it tells you that that decimal is behind that number. So that decimal went from behind this number to in front of the number. So what happened to it? What did we do? We went to the left how many times? Twice. Went to the left twice. And that's how we ended up at 0.25. So if you think about it, we moved the decimal to the left twice to get 0.25. But when I actually did the fraction, I divided by what number? When I did this fraction, what did I divide by? I divided by 100. I divided by 100. So when I move the decimal to the left, that's the same as dividing by 100. Does anyone understand why? Let's do like a little experiment real quick. If I have the number 1, so I'm going to tell you, if you go to the left, if you move the decimal to the left, that's division. So if I move it to the right, what is that? Multiplication. Okay, does that make sense? So if I move this decimal 1 time to the right, bam, what happens? What I put here? So I took 1 and multiplied times 10. So when I move it to the right once, I'm multiplying by 10. When I move it to the right twice, what number do I get? So I'm multiplied by 100. If I move it to the right 3 times, I'm multiplying by 1,000. If I move to the right 4 times, I'm multiplying by 10,000. Does that make sense? So anytime you move that decimal, it doesn't matter the number. If you move the decimal to the right, you multiply that number times 10. If you move it once. If you take that number and you move the decimal to the right twice, you're multiplying by 100. What do you think happens if I move to the left once? I'm dividing by 10. The way I would say that number is 0.1. I don't know why I messed that up. But if I move to the left, again, I would just say that's a 10th. If I move to the left twice, I get 100ths. So I divide it by 100. If I move to the left 3 times, that's 1,000ths. So I divide it by 1,000. If I move to the right 4 times, that's 10,000ths. So I'm dividing by 10,000. So I did all that to show you that the reason why we can move the decimal to the left twice when we go from a percent to a decimal is we're really dividing by 100. And when I go from a decimal to a percentage, I move it to the right twice, which is really multiplying by, what happens when we did it twice? Multiplying by 100. All right, so let's go to 85%. It says 85%. That means that it's 85 out of 100. And instead of actually dividing 85 by 100, I can use a shortcut and take 85 and do what to the decimal? To the left, how many times? Twice. If you forget the number of times to move it, just look at the number of zeros. How many zeros in 100? So I'm moving to the right. Moving to the left. 1, 2. So my decimal is 0.85. Does that make sense? The next one, it says it gives us the fraction 40 out of 100. So what is that as a percentage? What is it? 40%. Good. What would that be as a decimal? Instead of actually dividing by 100, I could take 40 and do what, Ellie? Move the decimal to the left 2 times. That's the same as dividing by 100. Miss Trowbridge, what would be my decimal? You do know. Please. Put a cherry on top. Pretty please. Kumash. What's my decimal? Point what? 0.40, or I could just say 0.4. Does that make sense? Okay, so a percent can also be written using a percent bar. or a percent proportion. So we're going to set up a percent bar and a percent proportion for these two. First of all, that percent bar has 5 spaces. Our fraction says that it's 1 out of 5. How many spaces should I be shading, Tavi? 1. So 1 out of 5. That's our that we're done with the percent bar. Now the question is, what percentage is that 1 out of 5? What is 1 out of 5 as a percentage? So here's how we figure that out. We make a proportion. Proportions are very useful. What I know about proportions is this is a part to whole relationship. If I look at that first fraction, what would be the part? Emily, 1. What would be the whole? Addison, 5. So the part to whole relationship with the fraction is 1 to 5. 1 is the part, 5 is the whole. Now, if I want to make it a percentage, I already know the whole for every percentage. What is it? What do we say at the top? The whole for percentage is always a percentage is a part to whole ratio where the whole is always 100. So if I come down here, if it's a part to whole relationship, the whole is always 100 because it's a percentage. What do I put up here at the top? If I didn't know, what would I put here? I don't know what the percentage is. X. Okay, now we can look at solving it because I heard the answer already, but I don't want the answer. I want us to understand what's happening in this proportion. Now, what can I scale this proportion? Meaning, can I solve it without cross multiplying? Can I look at the number relationship and figure out what X is? How, Tavi? Right, so I can look at what is 5 times what number gives, because it's going to be a good whole number. 5 times what number gives me 100? Tavi? 5 times 20. So if I do it to the bottom, I can do that to the top. 1 times 20 is what? So X equals 20. So what's my percentage? 20 out of 100 means 20%. So 1/5 is 20%. Now, let's say I didn't know how to scale because a lot of you looked at me and didn't know what I was talking about. What should I do? I don't know what that means. What should anybody? I don't care who says it. What should I do if I don't know how to scale? Not divide. I have a proportion. How do I solve a proportion? We should know. We've done them for the last week. Just say it. What is it called when we do that? What do we call that? What kind of multiplication is that? Cross multiplication. So it's 5 times x, which is 5x, equals 1 times 100, which is, now what do? I divide by what? Divide by 5, x equals 20. Guys, we have to know if it's a proportion to cross multiply. You cross multiply. You multiply whatever's on the bottom times the one across from it. The same thing for the other two numbers. Cross multiply. If you don't know how to scale, cross multiply. All right, so let's look at the next one. It says 3 out of 4. So I have 4 spaces. How many spaces should be shaded? 3 out of the 4. 1, 2, 3. All right, so the part to whole relationship here. What's my part? 3. What's the whole? 4. I want to make it a percentage. I know that the whole for every percentage is what? 100. Do I know the percentage though? So what goes here? X. Now, if I don't know how to scale, let's say I don't know what I'm doing. How do I solve this? Everybody, how do I solve it? Everybody, how do I solve it? One more time, because not everybody's saying it. You're not too cool for school. How do I solve this? Okay, so we cross multiply 4 times x, which is 4x. Then I multiply 3 times 100, which is 300. Then I divide by 4. Divide by 4. 300 divided by 4. 4 goes into 30. 7 times 4 is 28. That leaves 2. 3 9 0. 4 goes into 20. 5. So x equals 75. So x is 75%. Does that make sense? Now, if you did know how to scale, what you would say is that 4 times what number gives you 100? Tavi? 4 times 25. So 3 times 25 is 75. So that's how you would scale. Any questions? All right.